Hello and welcome back to another episode on the channel by me, TheWiseJames. This is a kind of special edition, I guess, because I've had a request to explain dark matter to people. So, let's get into it. Now, some of you may not know what dark matter and dark energy is, so it's pointless me explaining to you at this point in the video how I've actually solved it, in my opinion. It's yet to be proven, but you'll understand. So, what we're going to do is I'm going to watch a video with Briancox and Joe Rogan. You've probably heard of Joe Rogan. If you don't know who Briancox is, he is a famous TV scientist. He's always talking about space and physics and stuff. One second. So, if you don't know who Briancox is, that's Briancox. You will know who he is. He's very enthusiastic about science and physics. So, now first of all, although I have, in my opinion, solved this problem he is talking about, that doesn't mean I think I know more about physics and the universe than him. Like, we all are good at something and bad at some other things. I probably do know more about fixing computers than Briancox. I probably do know more about females than Briancox. I know more about football than Briancox. But that doesn't mean I think I'm smarter than him, but that also doesn't mean I think he's smarter than me. I think all humans are both smart and dumb. Depending on the subject will depend on their ability. Like, it's quite obvious to me, but that's not how everyone thinks. Most people will think one person is stupid or dumb. They won't think both. So, we'll watch this so they can explain what dark matter and dark energy is to you all. And then I'm going to explain my solution, what I believe it is, and how I think I've solved it. I'm not even going to put a tinfoil hat on for this one because I think it deserves a bit more respect than mocking this. It is one of the biggest mysteries in science, okay? So I've quite enjoyed walking around for the last few years, knowing full well what I've done and how no one else knows, and even if I told them, they wouldn't believe me. So I just get on with my life and enjoy it. Nobody knows the things I've done. It's been quite nice. So let's get into the video, though.
Possible that some new form of particle, something else could be discovered.
Yeah,
that we don't know about yet.
Because we know.
Well, yeah, exotic matter is actually quite a cutting field in science, you know. Sorry, I'm not trying to interrupt too much. You know, these are smart guys doing a good job.
Almost know that there are other particles out there in the universe.
We almost know?
So a thing called dark matter.
Yes.
So we look out into the universe and we see that there's a lot of stuff there that's interacting gravitationally, but is not interacting strongly with the matter out of which we are made and the stars are made. So it's almost certain that that's some form of particle, that fits beautifully. And we see lots of different observations, the way galaxies rotate and interact, and even that oldest light in the universe, the so-called cosmic microwave background radiation, we see the signature of that stuff in that light as well.
So what he said there is that we although we can't examine dark matter directly like we do everything else, we suspect it is a particle, but we don't know what that particle is. So we know it's there, we just don't know what it is. That's what he's saying. So I'll get into what I think that is. So right there. I can't remember the name of it. So you'd be looking at an anti-graviton. Either a graviton or an anti-graviton. However, we haven't proven the existence of this particle yet, but that's what scientists think is the particle responsible for gravity. It's called the graviton. So if dark matter is gravity in another form, which we'll get into later, it would either be a graviton or anti-graviton. Possibly a Xeon, I think. What, maybe. I'm not an expert in particle physics. I'm just here with the solution, lads, alright? I'm just here to solve the problem. I'm not the expert in all the little details, alright?
So we think that there's some other particle out there. And to be honest, we thought we would have detected it, I think, at LHC. We have lots of theories called
LHC stands for Large Hadron Collider. The Large Hadron Collider is the particle accelerator they have in Europe. Large Hadron Collider. Large Hadron Collider, the world's largest high energy particle accelerator. That's what it is. You've all seen it before. This thing here. So I would like to point out that they're going to build this new one called the Future Circular Collider. And realistically, it's going to be a bit of a waste of money. Because if they want to find these particles they're looking for, they're going to need to build one of these particle accelerators in space, away from a gravity source. Because the Earth's gravity is interfering with their experiments and giving them varied results that they wouldn't have in a zero-G environment, or as close to zero-G as possible. So they think that building this even bigger energy collider is the next step. I think, personally, building a smaller one in a zero-G environment is the next step. But what do I know, you know? Just some crazy guy on the internet. Fucking hell.
supersymmetric theories that make
Supersymmetry he's talking about there. You might have heard about that on the Big Bang.
predictions for all sorts of different particles that would interact weakly.
Bloody adverts. Get off my screen. How dare you interrupt Briancox.
With normal matter. And I think it's broadly seen as a surprise that we haven't seen them at LHC. So that just...
Maybe our equipment just can't detect them in the time before the Earth's gravity destroys them. Or maybe they don't form correctly because of Earth's gravity disrupting the results or varying the results. I know, like, it seems stupid that I would be saying this and Briancox wouldn't know this. I'm sure he does, but you have to remove variables in certain scientific experiments, and the hardest variable for them to remove is gravity. So they don't really need a bigger energy particle accelerator. They need a different environment for the accelerator, okay?
may well mean that either they're a bit too massive, so we need more energy to make them, and we just haven't quite got enough.
You'd also be able to solar power it a bit, you know? Just saying.
Or we're not making enough of them often enough to see them, which is one of the reasons we're upgrading the LHC. So we also look for them, by the way, directly. So we have experiments under mountains. We bury them under mountains so the cosmic rays from space don't interfere with them. And we're looking for the rare occasions when these dark matter particles bump into the particles of matter in the detector. So because the idea would be this room's full of them. I mean, the galaxy's swimming with dark matter, as far as we can tell.
I mean, that would be the case, Briancox, but theoretically, when matter meets antimatter, one of them gets destroyed. Like, not always, but usually, right? So, if theoretically this dark matter is an anti-graviton, as soon as it comes into contact with gravitons, it would have a problem, wouldn't it? Like, so wouldn't the anti-gravitons be repelled from the Earth rather than attracted? I mean, I'm not a physicist. I like physics, basics and stuff, but I'm not an expert. I'm just thinking, you know, if it is an anti-graviton, then it wouldn't reach underground of the Earth because the Earth's gravity would repel it, or there would be a problem because it hit so many gravitons on the way. Like, I don't know. We'll carry on.
But it interacts very weakly with this matter, so it doesn't bump into us very often. So we're looking for the direct detection of it, and we're looking to make those particles at LHC.
So it's everywhere, but it doesn't interact with us.
Very weakly. So it interacts through gravity, and the archetypal part.
At this point, I would like to point out the person who came up with the concept of dark matter. I think is friends with a famous astrophysicist called Neil deGrasse Tyson. You've probably heard of Neil deGrasse Tyson. Neil deGrasse is a legend, to be fair. Absolute legend. This is Neil deGrasse Tyson. Very famous astrophysicist. Very famous black scientist. If anyone ever told me that, they were racist and they think they're smarter than black people, I can simply point to him as a classic example of, no, you're fucking not. Right? No, you're not. So, one of his friends or people who was, I don't know, when he was college or something, was working with a theory of dark matter, and they called it dark gravity. So Briancox here is kind of working on the premise that it interacts with gravity, whereas I'm seeing it from the perspective it is gravity in a different form to what we normally expect, right? That's my position, essentially.
Particle that's everywhere that doesn't interact strongly is a neutrino. So we do know about neutrinos, we've detected those. And there are something like 60 billion per centimetre squared per second passing through your head now from the sun. So they get made in nuclear reactions in the sun. But they go straight through your head and then actually straight through the earth, pretty much. Occasionally one of them bumps into something. And we can detect those because there are so many of them going through. But we only detect, I don't know, 1 or 2 a day.
And the idea is that dark matter encompasses an enormous percentage of the universe.
Yeah.
I think it's 80%. Before Briancox corrects me, I'm going to say 80%.
So it's 5 times as much matter is dark matter than is normal matter. And the number is 25% of the universe. So roughly speaking, about 5% of the universe is normal matter, stars and gas.
Yeah, so 80% of the universe is dark energy and dark matter. I got it wrong. Not 80% for dark matter. It's 80% is dark matter and dark energy.
25% is dark matter.
Yeah, so 5 normal matter, about 25 is dark matter, and about 70 is dark energy.
That's the other thing. I was
The other
gonna ask
thing.
you about.
Yeah.
Yeah. So
I've also got the solution for that. We'll get to that as well.
what the hell's that?
Don't know.
Nobody does, Brian. Nobody does. But don't worry. Don't worry. I will tell you at the end of this video. Don't worry.
Know what it does. So again, we go back. We talked about Einstein's theory earlier. So Einstein's theory, which works spectacularly well, says that if you put stuff into the universe, as we said before, then it warps and deforms and stretches, and it very precisely.
Imagine being able.
How dare these adverts interrupt Briancox when he's talking?
Tells you, given the stuff that you put in it, how much does it stretch, and how does it stretch, and the measurement we have is how it's stretching. So we observe, the thing we observe is how the universe is expanding and how that expansion rate is changing and how it.
See, dark energy relates to the expansion of the universe. So a ball that's like this is not like expanding, okay? Whereas dark matter kind of is more in between the fabrics of that, affecting things like the spin of galaxies and the creation of stars and things like this. So dark energy and dark matter are 2 separate things that seemingly do work interlinked, but we'll get to it. We will get to this. I know this is very complicated. Normally, I'm posting stuff about racists and the far right, bullies on Facebook, battlefield stuff. So this is like usually above the pay grade of me. So, but we'll do it. We'll do it.
Changed over time. So we have very precise measurements of that. So then we can use the theory to tell us what's in it, given that we know how it's responding to that stuff. And that's how we discovered dark energy. So we noticed that the universe...
Dark energy.
versus expansion rate is increasing. So the universe is accelerating in its expansion. which is exactly the opposite of what we thought.
Yeah, so for many years, science believed that the expansion rate of the universe was slowing down, because obviously a reaction should only have so much energy that it should run out, and then it should slow down. Like, it doesn't just keep going faster and faster. So from science perspective, some scientists, they believed that the universe was still slowing down, but it's actually speeding up in the expansion, which would indicate the reaction that birthed our universe is still in its infancy. It's still in the early stages of its reaction. For example, if you have a chemical reaction in chemistry, first of all, the components need to be in place before the reaction can occur. So, for the Big Bang to occur, there had to have been something in place beforehand for the Big Bang to occur, which, current best theories, is a black hole collapsed into a white hole. Boom. That's the Big Bang, right? That's the best theory I've got so far on that. So, in the early stages of that reaction is kind of the most volatile, it gets faster and faster and faster until it runs out of the energy and kinetic energy to sustain that increase in growth, and slows down in growth. Eventually slows down and stops, Nearly every reaction you can think of. So why would the universe be different? So what that suggests to me is that we are in the very early stages of our universe. The very, very early stages. Infant stages. The reaction is only just done. It's just happened. In the time scale of the universe. The age of the universe lifespan could be 100 trillion billion years, and we're only 13 billion years into it. So the equivalent of a 1-year-old child, basically. Like, our timescale is not the same timescale as everyone else's in the universe, if that makes sense. Stars live for billions of years, sometimes only millions.
Now, this is in the 1990s that we discovered that. So
I remember. I was only a boy. I remember. It was a big thing back then. It was a really big thing. I think it was Hubble who confirmed that, wasn't it? I could be wrong.
we can work out what sort of stuff and how much of that stuff you need to put in the universe to make that happen. And that's where we get these numbers from.
Was there resistance to that when that was first proposed?
Yeah, I remember one of my friends at Brian Schmidt got the Nobel Prize for that. And then
Whoop whoop. He was on Big Bang Theory as well, I think. But you know, when they're offering out a Nobel Peace Prize to Donald Trump, I honestly think that the Nobels have lost their value. Like,
I remember I talked to him and he said he was a postdoc, I think, at the time, so a young researcher, and he was making measurements of supernova, the light from supernova explosions, which are so bright that you can see them, hundreds of millions, billions of light.
A supernova is when a star explodes and goes, poof, okay.
Like years away. And he noticed that if you look at the data, the light is stretched in the wrong way. So we look at the stretch of light as it travels across the universe, and the universe is expanding. It stretches the light, so it changes the colour. And he noticed that there was a discrepancy, which said that the expansion rate is speeding up. It's been speeding up for, I think something like 7 billion years or so. It's been speeding up. So he thought that he'd done something wrong, because so he checked it, and he couldn't find anything wrong. So
Ironically, this is the problem I've had for 10 years on dark matter and dark energy. Like, I've had this theory, and I can't prove it wrong. So I'm thinking I must have been making a mistake. So I honestly try and get physicists to prove it wrong. I try and get scientists to prove it wrong. I try and teach it to AI and get AI to get it to prove it wrong. Like, I've been trying for 10 years to get people to prove me wrong, because it's hard to grasp the belief that I'm the guy who solved this problem. Like, it's hard to believe, even for me. So, but I can't prove it wrong.
did what a good scientist does, which is he published it so that somebody else could find out what he'd done wrong. And
That's what I've done. But I can't make a scientific paper the way he did, because I'm not a university student. Like, I've got no experience making scientific papers. So it'll just be rejected out of a formality. It's not in the right order, or this isn't right, or that isn't right, or you didn't reference this, blah, blah, blah. I can't be arsed with that shit, right? I've told you what dark matter and dark energy is for 10 years. It's been publicly available online. I tell people on a regular basis, trying to get them to prove it wrong. That is, because it's publicly available, published, it is publicly published. Like, a scientific journal isn't going to print a nobody anyway. Like, I could try and write a paper, but I wouldn't do it justice. So I'm telling you what it is on this video.
Said that he thought it would be the end of his career. He thought it'd be a laughing stock, and he got the Nobel Prize because he was right. It is stretching.
Wow.
It's a great lesson. It means that if you're sure that you can't see what you've done wrong, then you publish it. It goes back to that thing about humility we talked about earlier. What we're not trying to be right. We're trying to find out stuff. And
that's correct. I'm not trying to pretend that I'm somehow the most knowledgeable about space and how I'm smarter than everyone else. Although I do go around saying I'm the smartest man in the world. But that is to compensate for about 7 years ago, I was held under the Mental Health Act. Not long after working out dark matter, actually. I was held under the Mental Health Act in the UK, and I was being treated like a man who was incapable of looking after myself and incapable of being a safe member of society. So because I was treated as incapable, I've kind of gone really out of my way to prove how capable I really am as a response to that. So I call myself the smartest man in the world as a coping mechanism or compensating mechanism for the world deeming me incapable when I was actually one of the most capable men on the planet, okay? So I have got my reasons. If a man can walk around in a dress and call himself a woman, I can solve the dark energy and dark matter problem and call myself the smartest man. I still know there's humans out there who are smarter than me. They just haven't applied their intelligence. So they have the capacity of higher intelligence, but they haven't used it. So I don't see them as smarter than me. I believe people have the higher capacity of intelligence than me, and there's people better at me than things that I'm good at, yeah? Sure, I'm not the best at everything. I'm not the best at some things. Sure, But I am very good at solving problems. In fact, I've been paid by various people for 20 years to do it. Apple, the UK government. I'm literally very, very good at solving problems. I've got personal problems, that I struggle to solve, but I've got the credentials, trust me.
so a good scientist will be really happy if they turn out to be wrong because they've learned.
I would be really happy if I was wrong. I would, because nobody knows what dark matter is or isn't, and nobody knows what dark energy is or isn't. So if someone can prove me wrong, I would help science progress. So if I'm right, I help science progress. If I'm wrong, I help science progress by being wrong. So either way, I help science. It really doesn't bother me. It really doesn't bother me which way. Obviously, I would prefer to be right, and I do believe I am right. But I would also be happy to be wrong. Like, you've got to try. You've got to try in this world. Why not? I can't prove it wrong myself, and I can't get anyone else to prove it wrong. So why would I think I'm not right? Charles Darwin didn't even print his book of evolution. He died and didn't print it. So if Charles Darwin doesn't have to publish a scientific paper to prove evolution, he just writes a book and hides it under his bed, then I can write the solution for dark matter and dark energy on the internet and nobody knows about it, and it has to be accepted the same way. Like, I don't see how that's any different, personally. He didn't technically publish his scientific papers on the theory of evolution. It was a book he hid until he died. Whereas I've published all my theories online in various places, so what do I have to do?
Something.
Now,
It's good that he took
Yes.
that path because he got the Nobel Prize.
now, when he received the Nobel Prize and this concept started being
I would rather the Nobel Prize went to someone who proved me right, rather than me for being right, because they'll have to put in the work to prove it.
discussed, what was the initial reaction?
I don't really care for some prize. I care more about being the guy who was right than the guy who got awarded for proving it, if that makes sense. Because then I would be the first human who knew the right answer. I would be the guy who worked out the answer, and someone else proved me right. I would rather be the guy who's right than proving some guy right.
Well, it's interesting because it's allowed.
Oh dear.
In Einstein's theory, and it was in Einstein's original theory. So it's got a name. It's called the cosmological constant, and that's it's just allowed in the equations. And Einstein actually introduced it initially because Einstein's equations strongly suggest that the universe is expanding or contracting and not just sat there. So even before we'd observed anything, Einstein had a theory that suggested that the universe is just not static, and actually really strongly suggests that there's a beginning. Right, so the theory itself, on its own, suggests that you can see that if the universe is stretching today, then it must have been smaller in the past, right? Everything must have been closer together, let's say that. There's a man actually called Georges Lemaitre who worked independently of Einstein, but at the same time in the early 1920s, before we even knew there were other galaxies beyond the Milky Way. And they noticed that the equations suggest the universe might be stretching. And so he wrote to Einstein and said, your theory suggests there was a day without a yesterday. Because he thought, if everything's expanding now, then it must have been closer together in the past. And so there might be a time when it was all together. And he was a priest.
Yeah. So, at one point, our universe, in its current state, didn't exist because it wasn't an expanding thing outwards. It was just something else. There was, if you go back enough days, there was no yesterday. That's why the age of the universe is estimated to be 13.8 billion years old. They've used this calculation to work that out. And everything we found and observed seems to confirm this.
So he's a Belgian priest. So I think, I wrote about this, now it's kind of my interpretation of it, but I think that he was more predisposed to accept what the equations were telling him, because a beginning, an origin for a priest is really a nice thing, because it tells you the creation event.
Yeah.
And Einstein tried to dodge it and put this allowed term into his equation, which is almost the stretchy term, to say, well, if it's all kind of contracting or something, can I put something in to make it stretch a bit to balance it all out so it can be eternal? So, and you can't make it eternal that way. But he tried it. Then he took it out and called it his biggest blunder.
Taking it out was his biggest blunder.
No, he called putting it in his biggest blunder.
I think calling quantum mechanics spooky science was Einstein's biggest blunder. Like, he didn't believe quantum mechanics was real. Like, people had to literally convince Einstein of quantum mechanics. You know, I know Einstein's got this incredible reputation, but he was just a man. Like me. Like Brian. He was literally just some man. And because of his amazing abilities and achievements, he's gained this almost godlike status as like the demigod of wisdom for the human race at the minute. And I get it, I get it. It's fine. It's just, he was just a man, He did make mistakes, even in science, even in physics. He also had dyslexia. He made many spelling mistakes. But if you go on Facebook and Twitter and make a spelling mistake, people will think they're smarter than you. Like, so they would have thought they were smarter than Einstein.
Or at least some people think what he'd done was miss the prediction of the Big Bang, really. So by trying to fiddle around to have a static universe that's stable, he missed what the equations were screaming. His own theory was screaming to him, which is that, no, the universe expands or contracts. And he missed it, right? So I think that's probably what he meant by biggest blunder. But in any case, he took it out. And then later, in the 1990s, it turns out that, no, it's there. But it's really small. It's tiny, tiny effect. But it's still dominating the universe now. and it will dominate even more in the future. So we think that we're in a universe that will continue to expand, essentially doubling in size on a fixed timescale, which is about 20 billion years. So within every 20 billion years into the future, forever, unless something happens, the universe will continue to expand and double in size.
Glow up, glow more, glow less. Glow up with new Nivea Luminous Skin Glow Serum. Fast delivery.
Oh dear, bloody adverts. So that's the end of the video on what dark matter is and what dark energy is. So a good example of how we know dark matter exists is because we can look at the galaxies out in the universe, and they're supposed to move in this certain way, you know, but for some reason they move differently, and we are able, like, for the spin of some galaxies, they're spinning faster than they should be spinning. So there has to be something out there that, you know, it is causing entire galaxies to spin faster than they otherwise should be, and moving galaxies in ways they shouldn't move otherwise. There has to be something, doesn't there? And we watch and observe this. We can't directly detect it because it doesn't interact with normal matter and normal material. So we can't directly see it, detect it, you know. We can only observe its existence by how it interacts in these hidden ways that without the numbers and mathematicians, we would be blind to. But because of the mathematicians and stuff, we know. Literally, we know. So I've got basically two versions of my theory here for you. Now, some of you viewers out there are not the most scientifically advanced, and some of you are quite scientifically advanced. So I don't want to insult the advanced people by giving them the simple version, and I don't want to insult the non-advanced people by giving them an advanced version that kind of is full of terminology they might not understand. So I'm going to give you the simple version first. So my theory on what dark energy and dark matter is quite simple. Now, I've always known that dark energy and dark matter is light and gravity, okay? Let me just lay it out. We've got these two unknown forces in the universe that make up 80% of the universe, that act like gravity and light, behave similar to gravity and light, have more power than everything else in the universe we know of, except gravity and light. So I just think humans have overlooked the ability of gravity and light, the same as we have for hundreds and thousands of years. Like, we've always overlooked gravity and light and their ability. So why would today be any different? So I came to the idea that that's what it was. And for years and years and years, I couldn't really work out how it was light and gravity, to be honest. I've always known it's light and gravity ever since I first heard about it. But I couldn't explain how it was light and gravity. So, one second. So about the age of about 2017, I was being mistreated by the UK government and wrongfully treated, tortured essentially, but we'll not get into that, and treated like I was incapable. And I took it as great insult, like major insult. I've been looking after myself since I was a boy. To deem me as incapable of looking after myself and start jabbing me with needles against my will, it was a fucking joke. So I went out of my way to prove how I was capable, including coming up with like a political manifesto in the UK, which, funnily enough, 3 of my policies are now in place. Like I got them in place without even becoming Prime Minister. People just stole them and passed them off as their own. But I've got the evidence online proving it was me, so it doesn't really matter. And I also tried to improve Einstein's theory of relativity. So instead of E equals mc squared, I believe that it didn't really represent everything in the universe. Because yes, we have energy, and yes, we have mass, but it doesn't really sit still. So I figured we should put an F for force on the end. So I put E equals mc squared equals F for force, right? With some parentheses, brackets around the E equals mc squared. Because the sum total of the energy and the mass will always be the total force, you know. You can't have more force than the sum total of energy and mass in the equation. And I don't believe force should be derived from the energy and mass within it, as it does in mathematics and from Einstein. I believe it should be separate as a simplified version and a simplified method. But, of course, theoretical physicists disagree. I'm just an idiot with no clue. But from my perspective, I did what Einstein did to Einstein's work. I think he left out the force. Like, he should have used the force. It should have been bracket E equals mc squared bracket equals F for force. Because the sum total of the energy and the mass will always be like the force. And the force is the movement of the energy and mass throughout the universe. If you just have E equals mc squared, there's no movement in there. It just represents the mass and its energy. It doesn't represent the movement. You've got to derive that within the formula when it should be alongside it, because it's the two values combined create the force. So you shouldn't derive it between them. You should work it out from them, if that makes sense. So from my perspective, I kind of improved Einstein's theory of relativity, and no one accepts that, and I don't care because it's so insane, even I don't believe it, but that's what I did. And then I also came up with loads of inventions to try and help the human race, like if we change the design of solar panels to solar trees, shaped like a tree, they would be more energy efficient than our current 2D methods. We should change it to a 3D design of a tree, because Mother Nature has already worked out the best design for photosynthesis. So why don't we just copy nature instead of thinking a flat sheet is the best thing, when clearly a three-dimensional surface is? Trees have worked it out. Just copy a tree's design with solar panels. Bosh. Job's done. I came up with loads of different inventions and ideas, like an energy solution that involved a magnetic levitation track with a magnet going around it, and a copper coil, and electric generation methods. And so instead of using a nuclear reaction or burning coal and steam to move a magnet, you just put a magnet on top of a circular track that's a magnetic levitation track, put it in a chamber, and then suck all the air out so it's got no air resistance, so it's got as little friction as possible. And that magnet going round, you're doing the same thing that you do with a turbine or a nuclear reaction or a steam engine or burning coal, except you're just doing it with a magnet. So I was thinking it's probably more efficient than like a lot of things. Like, surely, like you're harnessing the kinetic energy of a high-speed magnet that is moving because of a bigger magnet. Like, theoretically, it should work, but I'm not an expert, so I just handed it to the internet. And another one was the dark energy and dark matter solution. So this one, where's my cigarette? This one, basically, I had to think about it, like, dark energy, dark matter, biggest mystery in science, fine. I'll have a crack at it. And I just thought, the universe is like an ocean. It's like an ocean, isn't it? Of waves. Except those waves aren't water. It's gravity and light. And what mechanics do we observe in the ocean that we should then theoretically observe in the universe? And I just twigged. Like, it's currents. Like, current systems. Like, differences in the wave or speed of moving particles and things, causing differences in the same thing to create these currents. Now, we have surface currents on the Earth for the ocean and underwater currents. Now, I know it sounds stupid that like nobody on the planet has thought that somehow dark matter and dark energy are wave current systems or similar to current systems, right? So we know that gravity waves are different. they're not all the same. Some have differently strength. Some are, they're different. All gravity waves are different from the different sources because they're different strengths. So the idea of different gravity waves creating a current system isn't really that far-fetched. Where scientists would rule this out is with light, because light's a constant. Apart from the fact it's not always a constant, is it? It depends on the medium it passes through. And it just so happens that when light passes through certain ionized clouds of gas clouds, it bounces more. And because we record the speed of light from A to B, and because it bounces more, it takes longer to get from A to B, right? So although it's still travelling at the speed of light, because the way we measure light speed from A to B, it's technically not going the speed of light. So there's a physicist out there who used ionized gas clouds and 130 mirrors or so to slow down light to about half light speed. Light to light speed. So light to half light speed. So the professor who slowed light to a slower speed is called, forget her name, sorry, Leen Vestergaard Hugh. I'm sorry if I got that wrong, Professor. I'm not perfect. I'm human. So she slowed down light, right? This scientist, female scientist, great work, slowed down light. So if she can slow down light, right? If she can slow down light, then obviously, why couldn't the universe? It reflects a lot, and we've got ionized gas clouds out there and various other things that could potentially do the same. So therefore, we create the possibility that light is travelling at 99% the speed of light here, and light is travelling at 100% the speed of light here, and it creates a current system. Which is where I start to suggest that dark matter is the gravity current system for the visible universe, and dark energy is the current or current-like system for the visible universe for light. Like, dark matter is gravity in a way we don't normally see, and dark energy is light in a way we don't normally see. So we could be talking anti-gravitons or anti-protons or generally gravitons in ways we could never imagine. Literally, we're talking about particles we've never found here. So I'm trying my best, I haven't got a degree in physics. I am just this lunatic on the internet. So don't think of me as smarter at physics than this professor that I've just told you about. I'm not. I just like to solve problems. So that's what I think it is. I think dark matter is a current system for the visible universe, similar to what we observe in our water oceans on Earth. Now, the reason I say this is I've got a strong belief that the overall rules of the universe and physics trickle down. So the same rules that are applied here on Earth actually apply to the whole universe. The same rules that apply to the whole universe trickle down to every galaxy, to every planet, to every star, to every atom and particle and nuclei in the entire universe. They all operate on the same laws. So, why would a wave system of gravity and a wave system of light not have the possibility of acting similar to other wave systems? So, from my perspective, I couldn't prove this wrong. And everything I found out suggested I was right. Every single person who's researched dark matter seems to come to the same conclusion as me, that it's gravity. They can't explain how, and maybe I can't and I'm wrong, but I've given it a go. And, one gentleman, I can't remember his name, thought it was a dark universe that was, somehow part of our universe, but like a dark dimension almost. Like another dimension on the other side of ours. That was one person's understanding of it. But again, they saw dark matter as gravity. Now, the creator of the dark matter concept and understanding also called it dark gravity. When I'm calling in anti-graviton, that is essentially the same thing as dark gravity. That would kind of be the same thing, right? So, there was a recent study that also came out that found out that the spin rate of galaxies was sometimes increasing, not decreasing. Like, so though some of them were spinning faster than we expect them to, some of them also, their speeds were changing. And that means something was either slowing it down or speeding it up, right? So everything I've ever read seems to suggest I'm right. And I would love to be proven wrong. So, the entire internet is welcome to try and prove me wrong. Have at it. The human race would really be grateful if we could work out this problem. And I've really given it my best. And I try my best to get people to prove it wrong. And nobody gets it. Nobody can. So, I will now give you the complicated version. Which I've got AI to tell you it for me. Because it's easier. Right? So here we go.
Title: The Wave Current Theory, a revolutionary explanation of dark matter and dark energy. Introduction. Imagine the vast ocean, where powerful wave currents dance and flow beneath the surface, shaping the landscape of the sea. Now, envision the universe governed by similar dynamics. I am James Pope, and I present a groundbreaking theory that reframes our understanding of dark matter and dark energy, not as elusive particles or forces, but as intricate wave current systems that echo the phenomena we observe in Earth's oceans. The concept of dark matter, the gravity wave current system. Dark matter, which constitutes approximately 27% of the universe, has long eluded direct observation. Scientists have inferred its existence based on gravitational effects on visible matter. My research suggests that dark matter is not a mere collection of particles, but is best understood as a gravity wave current system, analogous to the ocean's currents. Just as water flows and creates currents that influence boats and marine life, dark matter generates gravitational waves that shape the motions of galaxies and galaxy clusters. This wave current system contains energy and momentum that interact with the visible matter in a dynamic interplay. It explains why galaxies spin faster than the observable mass would predict. They are carried along these gravitational currents. The nature of dark energy, the light wave current system. Conversely, dark energy, the mysterious force responsible for the accelerated expansion of the universe, can be likened to a light wave current system. Envision how light waves propagate through water, influencing its surface and creating patterns. Dark energy permeates the cosmos, influencing the fabric of space-time itself and causing it to expand. In my theory, this light wave current system reflects the interface between energy and the structure of the universe. It flows in a manner that pushes galaxies apart as it interacts with gravity waves, creating an overall expansion akin to the rippling effect of a wave hitting a shoreline. This dual current system, gravity waves of dark matter and light waves of dark energy, provides a coherent framework for understanding the universe's behavior on both large and small scales. An interconnected universe, waves above and below. Just as currents in the ocean interact, the gravity wave current of dark matter and the light wave current of dark energy are intricately connected. They form a dynamic equilibrium, governing the cosmic landscape and determining the fate of the universe. This interconnected model allows for a more holistic understanding of cosmic phenomena, encouraging us to view dark matter and dark energy not as separate entities but as integral components of a unified cosmic system.
So yeah, that's my dark energy and dark matter theory. I have got other theories, but it didn't really tell you the full thing there. It kind of saved off a bit, didn't it? I'm going to have to tell you the rest of it. So we got up to system, did it? Where's system? Oh. Okay, right there. Wait there, everyone. Wait there. Let's do this differently. There we go. Yes, I'm not a robot.
UST as currents in the ocean interact. The gravity wave current of dark matter and the light wave current of dark energy are intricately connected. They form a dynamic equilibrium, governing the cosmic landscape and determining the fate of the universe. This interconnected model allows for a more holistic understanding of cosmic phenomena, encouraging us to view dark matter and dark energy not as separate entities but as integral components of a unified cosmic system. Conclusion: a call to explore the currents of the cosmos **. As we delve deeper into this wave current theory, we open new avenues for research and discovery. This paradigm shift invites astrophysicists and cosmologists to reevaluate existing data through the lens of wave dynamics, potentially leading to innovative observational techniques and experimental approaches. Dark matter and dark energy no longer remain abstract, intangible concepts. Instead, they become relatable systems governed by the same principles that shape our earthly experiences. By embracing this wave current perspective, we stand on the brink of a deeper understanding of the universe, an understanding that resonates with both the complexity and beauty of the cosmos. Join me, James Pope, in unraveling the profound connections within the universe's fabric and embracing the revolutionary potential of the wave currents that define our existence.
So thank you for your time and listening to my theory. I do have lots of other theories on things, including the Big Bang. I mean, I think the Big Bang's a white hole. So the life cycle of a black hole in the universe, nothing lives forever. And normally we suspect they will just kind of evaporate over time, slowly decay away. But I think in rare occasions, the black hole could lose its gravitational stability and the singularity would either explode or implode. And if you had a large enough black hole that lost gravitational stability, it would turn into a white hole. That's how white holes would exist. So we've never actually found a white hole. We've never observed a white hole. Sometimes scientists don't accept their existence. But some, like me, think the Big Bang is a white hole. Which would mean the Big Bang was created because a black hole lost its gravitational stability somehow. I don't know how that is. Don't ask me that. I wasn't there. And that created the Big Bang. How you can't get a chemical reaction unless the chemicals are in place before the reaction so that the reaction can take place. So the components for the Big Bang were there before the Big Bang so that the Big Bang could happen. That is literally basic high school chemistry. I don't need a degree for that, alright? So there you go. There was something before the Big Bang. I just told you how. It's basic science. Basic chemistry. You try and create a chemical reaction without the chemicals for that reaction. Go on, try it. Try it. See what happens, right? So anyway, thanks very much for watching. If you can prove my dark matter and dark energy theory wrong, great. Fantastic. Do it. Because you will do science a massive favour. If you can prove that dark matter is not gravity, and you can prove dark energy is not light, you will get a Nobel Prize. You will. But also, ironically, if you prove I'm right, and it is light and gravity, dark energy and dark matter respectively, then you also will get a Nobel Prize. So literally, anyone on the planet who can prove me right or wrong might get a Nobel Prize. Maybe. But it won't be easy. If it was that easy, someone would have done it already. I've been trying to get you lot to prove me wrong for 10 years. And I've now given up getting humans to prove me wrong and try and get AI to do it. So I would be extremely impressed if someone can do it. Extremely impressed. Thanks very much for watching. Have a good one. Peace.